Hello everyone. Am I audible? Hello.
Yes, ma'am. Are you? Yeah.
Okay, so how was your quiz one?
Can say it's
It was tough or easy or whatever we want to say.
i- it's
Have you
kind
done?
of intermediate, like medium difficulty, I can say.
Okay, okay. Anyone else who find it difficult or easy or any comments on that? Okay, nothing to say. Okay, fine. So, okay, yeah. So week six deadline is we have extended. So Friday is the deadline for week six graded assignment now. Okay.
But is it officially informed to everyone, ma'am? Or
Yeah, we have sent an announcement regarding the same.
okay.
Okay, yeah. Okay, so in week six, particularly, we have to study about the combinations. So permutation we have covered in week five. Is my screen visible? My screen is visible to everyone, right?
Yes, ma'am.
Yeah, so in week six, we have to study combination. Okay, so anyone would like to say something about the permutation that we have studied in week five? Why we use permutation? Anyone?
I think it's to know number of possible ways.
Permutation order matters and combination order does not matter.
Yeah. So both permutation and combination we use for selection of the things, but the difference is that if we are arranging the elements also, if the order matters, then we use permutation. And if we are doing only the selection of the elements and we are not worrying about the arrangements of the order does not matter, then in that case we use combination, right? So for example,
Hello, ma'am. I just wanted to ask one thing. Does the events occur simultaneously in permutations? Suppose we are selecting a six-digit number from a given digits. Then does it, after this selection of first digit only, we'll go for the next. So can we say that events doesn't occur simultaneously?
no, we are selecting the things at the same time, right? In that case, if you have six things and you are selecting five things, for example, right? So they will be occurring at the same time.
Then how does order, order should be, events are ordered, we say that, no? But in permutations, the order matters.
See, that is different thing. Okay, so what do you mean by order there is that if you are selecting two things, suppose we have A, B, C, and D, right? And you are
Okay.
selecting we have four alphabets here, and you are selecting two. Okay, so
Okay.
maybe I am selecting A and B. So if order matters, then AB and BA will be different.
Okay.
Okay, so for example, we are selecting two-person for two different roles, maybe captain and vice captain. Okay, so these two are the different positions, right? So maybe
Okay.
you are selecting A for captain and B for vice captain, or maybe you are selecting B for captain and A for vice captain, right? So in that case, both AB and BA are different from each other.
Okay.
Yeah. So in that case, we say that order matters.
So usually for combinations, order matters.
No.
For
Combin
permutations,
for permutation we use when the order matters.
okay.
Okay.
Do you mind? I mean, can you give any example? This time events because we are doing some assignments in EMQs in which the some events which doesn't occur simultaneously occur simultaneously. Can you give any example regard to differentiate simultaneous occurring events? Such, I mean that concept.
Yeah, simultaneously means that you are doing at the same time. Okay, and if they are not simultaneous, which means that whatever we are doing, that thing is not occurring at the same time.
So can we say picking up cards from the deck of cards is
If we are
a
doing selection like one by one, then they will not be occurring simultaneously. Okay, if you are selecting out of 52 cards, you are selecting 3 cards. Okay, in one time, so that will be simultaneous. If you are selecting out of 52, you are selecting one card first. Okay, then you are selecting other card, and then you are selecting the third card. Then it will not be simultaneous.
okay.
Okay, so for combination, let's take an example that in how many ways can we select 2 students from a group of 3 students? Okay, so suppose we have 3 students, suppose A, B, and C. Okay, and we just have to select 2 students out of these 3 students. So what can be the possible combinations? If we are just selecting the students and we are not worrying about the order or the arrangements. So it can be like maybe we are selecting A and B, or maybe we are selecting B and C, or maybe we are selecting C and A, right? So these can be the possible combinations. And in that case, order does not matter, right? Because we just have to select 2 students. It doesn't matter you are selecting A first and B second, or you are selecting B first or A second, right? So in that case, if you have A, B, and C, then these could be your possible combinations, right? So this is just for when your number of total elements is 3. Okay, if we generalize this formula of combinations, okay, so the definition will be the number of possible combinations the number of possible combinations of R objects from a collection of n distinct objects. Okay, that is denoted and given as so. What is the formula for combination? Anyone?
NCR.
Yeah, so we denoted by NCR, and the formula is n factorial divided by R factorial into n minus R factorial. Okay, and this NCR we can also write it like this in the form of binomial coefficient. Okay, so this is called as binomial coefficient. Okay, so NCR is also represented in this way. Okay, so this is the formula for combination. Okay, so we are selecting R objects out of N distinct objects. So we can use this formula now to the previous example. Okay, so we have N is equals to 3 and R is equals to 2 here, right? So 3, C, 2. Okay, so it will be 3 factorial divided by 2 factorial into 3 minus 2 factorial, right? So 3 factorial is equal to 3 into 2 into 1, right? 2 factorial is 2 into 1. And 3 minus 2, which is 1 factorial. So 1 factorial is equal to 1, right? So you can see that this is equal to 3 only, right? So 3 combinations will be there out of total n objects when we are selecting 2 objects. Okay, that you can see here that A, B, B, C, and C are the 3 different possible combination in this case. Okay, any conclusion in this part?
Hello, ma'am.
Yes.
Yes, I'm sorry I'm cutting in. I just want to ask about the extra activity questions that were given. So can you just explain it once? Like what is it about and how to do it?
So, extra activity, you can see the instructions are given on the portal, and you can see the instructions in video format also. Okay, let me for extra activity. So this instruction slide is there that you can check. Also, I think here also, I think you can find it one video. Okay, just watch this video in fast forward. There you can find some instruction regarding the same thing.
Yeah, it talks about the portfolio, like how to make the portfolio.
Okay, then
And
okay,
I'm confused, like I'm not yet like admitted. My qualified result will come out on 7th. So I'm like thinking if I like my Google ID right now. So is it possible that I'll be able to change it later, the ID given? Hello?
thing I will have to see. I'm not sure currently.
Maybe what we can do is we can start our work,
Mm-hmm.
and once we receive our official email address, then we log in using that and just replicate whatever we have done in our private email address and do that there. So maybe we can start our work, and once we receive our official address, we can post
Okay.
everything there.
Okay, okay. But like, can you give a glimpse of what is it actually? Like what if we like score activity points and what would that give us in the near future?
That is for now.
Sorry, can you please repeat?
I'm asking like, can you give a like brief about what is the activity points and what would like be fruitful to us like after submitting the assignments?
Okay, so how these marks, like how it will be evaluated and the bonus marks and also there will be some, I think, document where everything is mentioned, or I think you might have received an announcement regarding the same also. Okay, and as of now, from this term, you have to do 5 peer reviews. Earlier it was 3, but from now onwards, you have to do 5 peer reviews, at least 5. Okay.
Okay.
Okay, so keep this thing in mind because earlier it was 3, but now we have changed it to 5. So if you do peer reviews, then only you will get the marks. Otherwise, you will not get the marks.
Okay, got it.
Yeah, so we were discussing about the combination. So this is the formula for combination. Next, there are some useful results that we can remember for the calculation part. Okay, so one is that NCR. So formula of NCR is what? N factorial divided by R factorial into N minus R factorial, right? We can also write it like this: N factorial divided by N minus R factorial into R factorial. They both are same, right? Now I can write it as N C N minus R, right? So from here I can conclude that NCR is equal to NC N minus R. So do you all agree with this point? Right? So what is the practical meaning of this line is that the selection of, okay, selecting R object from N objects is same as selecting N minus R objects from N object. Okay, is this point clear to everyone? Yes or no?
Yes, ma'am.
Next is that NCN. So NCN will be equal to 1. Okay, you can check this thing by using the formula also, that NCN, which means N factorial divided by N factorial and N minus N factorial. Okay, so N minus N factorial will be 0 factorial, and 0 factorial is equal to 1. So it will be N factorial divided by N factorial. Okay, so both will be cancelled out, so it will be equal to 1 only. Okay, which means that if you have N objects and you are selecting all the N objects, so that you can do only in one way, right? You are selecting all the objects available. So that can be done in one way only. Okay, so this should be equal to 1. Also, NC0 should be equal to 1. That also you can see from the formula. Okay, so it is equal to N factorial divided by 0 factorial into N minus 0 factorial. So again, it will be N factorial divided by N factorial, which will be equal to 1. Okay. Is this point clear to everyone? Next we have is that NCR is equal to N minus 1 C R minus 1 plus N minus 1 CR. So you can also prove this fourth point also by putting the values. Just open the formulas and you will see that left hand side is equal to right hand side. And here R lies between 1 to N. Okay, is there any doubt? Okay,
ma'am,
let's see a question in this. Yes.
ma'am, do we use this when the order of the choices is not um, known? As in, does it really matter if we know the order? Because if we select, for example, if we select 4 objects out of n objects,
Hmm.
if we're concerned about the order of selection,
Then we will not use the combination. Okay,
permutation,
in
use.
that case, yeah, you have to use permutation.
Okay. Thank you.
Okay, so let's see a question. Okay, so the question is, in a exam, okay, in an exam we have total 12 questions. Total 12 number of questions we have. which are divided into two parts. Okay. Part 1 and part 2. In part 1, we have 7 questions, and in part 2, we have 5 questions. Okay, so total 12 questions we have. And out of these 12 questions, we have to attempt 8 questions. In total. Okay, and there is one more condition that we have to select at least 3 questions from each part. Okay, select 3 questions, at least 3 questions. At least 3 from each part. Okay, so this is the question. Now we have to find the number of ways in which we can perform this thing. Is the question clear to everyone? So in exam, we have total 12 questions, which are divided into two parts. Part 1, part 2. Okay, in part 1, we have 7 questions, and in part 2, we have 5 questions. Okay, and from the entire paper, we have to attempt 8 questions. Okay, and in those 8 questions, at least 3 questions we have to do from each part. So now we have to find the number of ways in which we can attempt the question paper. Okay, so anyone, how can we solve this?
Yes, so out of the first part, we can have 7C5 and or 7C3. So if we have 7C3 from, let's see, select at least.
Okay, so from
Okay.
first part, yeah, we are selecting 3 then.
Yeah, then I have to select 5 from the, so I will have 5C5 from the second part. And
Yes.
that would be 7C5 times 5C3.
7C5 times 5C3. Okay. Any other possibility?
Yes, I have 7C4 and 5C4.
7C4 and 5C4. Okay, any other chances?
Yes, but I have, but I no, I can't have. I would have if the third condition, but if I have the third case 0 plus 8, then the third condition violates for that. So
Yeah.
I can do and
Yeah, so only 3 possibilities are there. Okay, not 3 possibilities. I mean, these number of possibilities are there. Okay, we can make it like this. Okay, so either we are attempting 3 questions from the first part and 5 questions from the second part, or we can select 5 questions from the first part and 3 questions from the second part, or we can select 4 questions from first part and 4 questions from second part. Okay, now we can solve it and we will find the total number of ways in which we can attempt our question paper. Okay, so 7C3 is 7 factorial divided by 3 factorial into 4 factorial. Then 5C5 will be 1 only, right?
Madam,
Then,
both direction we can take, right? Both direction we can take, right?
yeah, sure.
Which means here how you selected 3 from 1 and another 5. Same way 5 and 3 also we can select, right? Okay, here order is not matter, right? So that's the reason combinations are coming. Okay.
Yes.
Okay.
Okay, now just solve these, do all the calculation. Okay, so 7C5. Okay, now we can use one result here. Okay, we have seen here that NCR is equal to NCN minus R, right? So 7C5, I can write it as 7C2 also, right? And 5C3, I can also write it as 5C2. Okay. So just for the simplification of calculation, you can use these terms. Okay, and for 7C2, if I solve it separately, you can solve it like this. That's 7 into 6 divided by 2 into 1. Okay, if you don't want to use the entire formula, this is just a shortcut to solve the combination formula. Okay, so like this. Okay, in this way you can solve this and find the final value.
Madam, I don't understand, madam. So here,
Yeah.
how you the second
Yeah.
step, how you reduced actually? So, uh,
This thing, huh?
so that one L, what is that L? L.
See, not L, it is it's 2, not L.
I'm sorry.
Where is L? This
This is a middle number. Yeah. Oh, it's 1. Huh? Okay.
Yeah, 1, not L. Okay, so
So
5C5 will be equal to 1.
okay, 5C5 1. Okay. And here, how you reduce it? 7C2.
Yeah. So we have seen this result that NCR is equal to NCN minus R. So if you have N is equal to 7, okay, and R is equal to 5, then according to this formula, so we have 7C5, right? Which is equal to 7C N minus R, which is 7 minus 5. Okay, so 7 minus 5, which means 2. So 7C5 is equal to 7C2.
But if you convert it to the value, it will match, madam. This one.
Yeah, sure, definitely both
Can
have same
can,
value.
is it possible to show, madam? So maybe you can understand. So in lecture also it told, but I am not able to remember how it's matching.
Okay, so 7C5, okay, so it is 7 factorial divided by 5 factorial, right? And
Yeah,
N minus
7.
R, which means
Yeah,
7
7
minus
minus 5,
5, which
2
is 2
factorial.
factorial, okay?
Yes.
Then we have 7C2, okay, which is 7 factorial divided by
2
2
factorial,
factorial into
then 5
7 minus
factorial.
2,
5
5
factorial.
factorial. Now you can see that both are same.
Yes, yes. So
Okay, 5
this
factorial into 2 factorial is same as 2 factorial into 5 factorial. Okay, so they both are same.
okay, okay. So it will applicable for anywhere, right? So
Yeah, it is applicable
any
anywhere.
combination, it will be applicable.
Yeah. So this
Okay,
is the general formula.
okay, that's all.
Anyone who solved this calculation?
Answer is 2100 is the final answer.
So let
For
me
when
solve it also. So this is 7C3 we can write, or okay, let's take it 7C4 only and 5C4. So do you understand this short trick or not?
yes.
Yes, madam.
Okay,
Yes.
so 7C2, which means if you have 7C3, then it will be 7 into 6 into 5. Okay, which means 3, which means you have to write 3 terms in numerator, and the denominator you just have to write 3 factorial, which means 3 into 2 into 1. Okay, so you can use this shortcut here and solve it. So 7C3, I'm solving it directly. It will be 7 into 6 into 5, then 3 into 2 into 1. 5C5, we know it is 1. Then 7C5, okay, so 7C5 will be 7C2 also, which is 7 into 6 divided by 2 into 1. Then we have 5C3. So 5 into 4 into 3. 3 into 2 into 1. Okay, then 7C4. Or we can use 7C3 also. Then 5C4. So 5C4 will be 5C1. Okay. Or we can open it also. Now just solve all these parts. So
Madam, sorry to interrupt us. Here, left and right, more space is there. Little more also you can zoom, so maybe you will get more space.
so that will be 35. And if you solve this term, it will be 175. Okay, and when you solve this term, last term, it will be 210. Okay, so the summation will be equal to 420. Okay, so this will be the answer. Anyone has any doubt in this question? Is this question clear to everyone? Okay, then I'm assuming that no one has any doubt in this question. So next question we can see. Okay, so suppose we have a deck of cards. We have 52 cards. Can you please mute your mic if you don't have to ask any question? So we have a deck of cards, okay, in which we have 52 cards in total. Okay, if you have to select 4 cards, select 4 cards. So in how many ways can we do this?
Yeah, 52C4 ways.
Yeah, 52C4. Okay, so in these number of ways, we can select 4 cards out of the 52 cards. Now, if we have to select 4 cards, but they all are from the same suite. Okay, so all the 4 cards so we have 4 different suits here, right, in the deck of cards. Okay, so from 4 we have to select 1, right? And then in one suite we have 13 cards in total, right? So then out of 13 cards, we have to select 4 cards. Is it clear to everyone?
No, what does the sweet thing mean? So of the same kind, you mean? So if say I have a deck of 52 cards, like are you asking all 4 cards are diamonds or all 4 cards are aces?
Yeah.
Okay.
Okay, so first we have to select one suit from all the four. Okay, so we will be having only one. Okay, then in one suit we have 13 cards in total. Then in 13 cards we have to select four cards, right? So that can be done in 4C1 into 13C4, which means 4 into 13 factorial divided by 4 factorial into 13 minus 4 factorial, right? You can solve it by yourself also. Next, if we have to select all the four cards from the same color, so all the four cards are of same color. So there are two colors in the deck of cards, right?
Yes, so you take 4C2 times the rest would be like 13C2, right?
No, we have to look according to the color. So there are two colors. Out of the two colors, we have to select one. Okay, then
Oh,
we
you are
have, yeah. So we have 26 cards of red color and 26 cards of blue color. Oh, sorry, black color. Okay, so then we have to select out of the 26. Okay, we have to select four cards out of the 26 cards of one color. Okay, maybe you are selecting red color or you are selecting black color. Okay,
Madam,
so that,
in addition to that, so same color and same suit, then one more combination we need to do, right? So 26 C1 color you selected. Then we have there is a two patterns are there, two suits are there. So again, 2C1 we can select, right?
see, in this we have to select the cards according to their suits. But here we have to select the cards according to the color and
Yeah,
not the suit.
I'm okay. See, whatever the
Hmm.
selected is okay. I'm just adding another. I'm just imagining if you add another one, same color and same suit.
Okay.
So then one more 2C1 it will come, right? One more 2C1, then 13C4 it will come, right? Cards are same color
Hmm.
and same suit, and four cards are we are selecting.
So
Means
in that case,
2 times 2C1 it
if
will
you are
come, right?
selecting, yeah, if you are selecting like color first, okay. So
Okay.
out of the two colors, you are selecting one color.
Yes. Then pattern. So 2C1 again, right?
And then we have two suits in one of same color. Yeah.
Yeah, 2C1. Then in this 13C4. Correct, madam?
Yeah, if you have this, if you have this condition, then yeah, in that case, it will be that.
Okay, okay.
But we have four different suits, right?
Yes, but they are selecting the color also. So in one particular color, we have two different suits, right?
We have to divide 52 into 2, right?
Okay, oh wait. So you are asking about that we have to select color first and then suit, right? Hello.
Yes, I think that's what he mentioned, right? You pick up the colors first. So first you arrange the colors. So there will be 26 and 26. So
Yeah.
and then from there that pack you pick the first the pick up the colors. First you separate the colors and then you pick up the choices of the suits.
Yeah. So we have two red like diamond,
Yes.
and this third are of red color, right? Okay, and the other two are of black color.
Yes, this
Uh,
third this is in black, but this one, the fourth one is present in both red and black.
What?
This, what do you call this? This you can get in both the red and black, right?
This is black in color, right? Not red. I as I remember. Okay, so we have two in red and two in black. So if you are selecting the color first, okay, so out of the two colors, you have to select one color. And then out of these two, you have to select one. And then out of the total 13 cards in one suit, you have to select select 4 cards.
Just one thing. So for the first, like the diamond, if you choose, that can be present in both red and black.
Okay, I will check this thing and then we will discuss it. But I think they both are in red color and they both are in black color. Okay, heart
Correct,
and
madam.
diamond are in red
Correct only.
color.
So diamond and dot in red
Red
only.
and
Yes, correct.
clubs are in black color.
Yes, yes, yes.
Okay, they don't have color interchanged in between. Okay. Okay, now these questions are clear.
Ma'am.
Okay, now let's take some other example.
Particularly that tutorial, that tutorial sums are there, madam. So they are explained in lecture and in that video tutorial in course page. Those things totally not able to understand, madam. So if you're selecting that one, it will be helpful for us actually.
The tutorial questions.
Yeah. So in this third tutorial, so
Okay, so questions we will be discussing in the doubt sessions. Okay, so there, if you want to ask those questions, you can ask.
okay, okay.
Okay, so from which tutorial you want to ask questions? So they like the solution is there, right? So are you not able to understand those?
Yeah. So not able to understand that one.
Okay, which one?
That is third tutorial, madam. So third tutorial problems.
Week 6, right?
Yeah, week 6 after lectures and all, na, there is
Hmm.
3 tutorial. There's a sequence of
Yeah,
tutorial.
so
They third one problems. Third one they explained, but difficult to understand actually.
okay. So see next question. So we have to select a cricket team of 11 players, okay, from the 17 players. Okay, in which 5 players can bowl. Okay, so we have to select 11 players in total. Okay, out of the 17 players, where out of the 17, 5 players can bowl. Okay, and now one condition is there that cricket team of 11 that we are selecting, okay, cricket team of 11 must include exactly 4 bowlers. Okay, so now what will be the possible common number of ways?
So 17C 4 times 17C7. So that would be one condition. And the other that would be there would be 17C5 times 17C6.
Okay, read the question again. So we have 17 players in total. Okay, out of which you have to select 11 in total. Okay, but in these 17 players, 5 players are there who can bowl. Okay, and out of the 11 players which we are selecting, exactly 4 bowlers should be there.
Okay, so the first one only be there. The second one won't be there because of.
Okay, so from the 5 bowlers, we have to select 4 players, right? Because 5 bowlers only we have.
Mhm.
Out of the 5, we have to select these 4 bowlers. Okay, now next thing is that from the remaining 12, right? 17 minus 5. So remaining we have 12 players, right? And now out of these 12 players, we have to select the remaining 11 minus 4 players, which is equal to 7. Okay. The question is that, okay, understand the question again. We have 17 players in total, which includes 5 players which are bowler. Okay, now in total we have to select 11 players. Okay, and they in these 11 players, exactly 4 should be bowlers, right? So we have 5 bowlers in total. Okay, you can write it like this also, that like this. So total we have 17. So now first we will select 4 bowlers from the 5 bowlers which are available. Okay, total we have 5 bowlers. So out of those 5 only we can select the 4 bowlers, right? Now from the remaining 12 players, we have to select the remaining 11 minus 4 players. Okay, so out of remaining 12, you have to select the remaining 7 players. Now is it clear?
Yes, ma'am.
Okay, now just use the formula of combination and you can find the value. Okay, so 5C4 will be 5. And this will be 12 factorial divided by 7 factorial into 5 factorial. Okay, now can you solve it? Tell me the value. What will be the value of this? Are you all solving the question or not?
Yeah,
12C7 is 792.
792.
Yes.
Okay. And the final will be 3960. Right? Okay. Is this question clear to everyone?
Ma'am, do you mind if I ask the next level for this question?
Okay.
If at all they want to select the team which has at least 4 bowlers.
Okay. So you are changing this statement that
Yeah,
not
such
exactly
questions
4.
also we encountered. So
Yeah, we have to select at least 4 bowlers, right?
yes, at
So in
least.
that case, you will make like this. So maybe in total you have to select 11 players.
Yes.
Okay, so at least 4 you have to select, right? So maybe out of 5, you are
You can add.
selecting 4, right?
Hmm.
Then it will be 12C 11,
7 itself.
7.
Yeah.
Another combination could be 5C5 and 12C8.
Oh,
Okay, and there cannot be any more combination because maximum we can go up to 5 because total maximum 5 bowlers we have.
okay.
And at least 4 we are selecting.
12C6, right?
Yeah, sorry.
6.
Yeah,
12
6.
is 6.
6 plus 5, 11. Okay.
Okay, ma'am.
In that case, you have to use this.
Similarly, we can do for at most or at least for similar.
Yes, yes. Yeah.
Okay.
Okay, so in this way, we can solve the question for combination. Now you need to remind the things in your mind that when you have to use permutation and when you have to use combination. And what is the relation between the permutation and combination? Okay, so in permutation, the main thing to remember is that order matters in that case, right? So in permutation, order matters. Okay, and in combination, order doesn't matter. Right? Now, if you see the formula, so NCR is equal to n factorial divided by r factorial into n minus r factorial. And the formula for permutation is n factorial divided by n minus r factorial. Right? So now, at place of this term, may I write it NPR? Right? Is it correct, right? Okay.
Yes.
So now we can conclude that NPR is equal to R factorial times NCR. Okay, so which means that number of permutations is equal to the number of combination into R factorial. Okay, so if you have, we have studied this thing that if you have n number of objects, then we can arrange n objects in n factorial ways. Right? So the same thing we are doing here. So we are selecting our objects first out of n and then we are arranging them. Okay. In permutation, what we do? We select items or objects or elements and then we have to arrange them also. Okay. And in combination, we just have to select. So in permutation is
Excuse me, ma'am.
Hmm.
How to understand in word problem that we have to calculate the permutation and combination
Yeah,
in
now we will see
problem.
some questions. In that you will understand whether you have to use permutation or combination or whether order matters or doesn't matter. Okay, so it will not be asked directly or it will not be mentioned directly in the question that order matters or not and you have to use permutation or
Yes, it
combination.
is there in that EMQ question assignments.
Okay. Okay, so I'm solving some questions based on these. Okay, now try to understand those. So for example, we have 8 athletes. Okay, we have 8 athletes who participates in a 100-meter race. Now we have 2 questions. Okay, so first is that in how many different ways can we uh, award gold, silver, and bronze medals? Okay, and the next one is that in how many different ways can we select top 3 athletes? Okay, so the first question is how many different ways can we award gold, silver, and bronze medal? Now, can you tell me that in the first question, order matters or not?
Yes, order matters because need to place them, right?
Yes. And the next is that in how many different ways? Okay, how many different ways are there? Okay, in which we select top three athletes. Okay, so in first one, total we have 8, right? And we have to give them award according to the gold, silver, and bronze. So it is obviously that we have to consider the order here, right? Because out of the 8 athletes, okay, we have to select first. First, we have to select 3 athletes, okay, and maybe these 3 athletes are A, B, and C. So maybe it is possible that A is getting gold medal, okay, and B is getting silver, okay, and C is getting the bronze. So this is one possibility. Or it is possible that athlete A is getting the silver, okay, and B is getting the bronze, and C is getting the gold. So now can you understand that here that order matters here, right? It is very obvious. Okay, so we have to use permutation in the first question because we can clearly see that we have to arrange them also. Okay, order matters here. So it will be 8, P, 3. Right? Now, in the next part is that how many different ways can we select the top 3 athletes. So in top 3, we just have to select 3 out of 8. Okay, we are saying that A, B, C are top 3 athletes, or we can say that C, A, B are the top 3 athletes. Okay, we are not discussing about their ranks. We are just saying that top 3 are these. Okay, so in that case, in the second question, we have to use the combination. So it will be 8, C, 3. Is it clear in this question?
Yes, ma'am.
Top three means so who is getting first, who is getting gold, who is getting silver. It's not important, but who are the people getting the medal?
Yeah.
That is only the
Yeah.
point, right? Yeah.
Yeah. Who 3 people or the athletes are there which are who are getting the medals? Okay. So we are just talking about the top 3, and we are not saying that A is getting gold or B is getting gold. Okay, that thing we are not discussing here. Okay, we just want 3 person who achieved the 3 ranks, top 3 ranks. Okay. Now the next question we can see. So suppose we have a class of 40 students. Okay, so the first one is that how many different ways can we select 2 leaders? Okay, and the next is that in how many different ways, okay, can we select captain and vice captain? Now here also it's very clear that in which question order matters and in which order doesn't matter? Can you guess it?
First question combination and second question permutation.
Yeah. So in first one, you can say that we just have to select two leaders. Okay, so maybe we are selecting A and B. So it doesn't matter that we are selecting, like we can say that we are selecting A, B, or we can also say that we are selecting D or X. So that doesn't matter. We have to select two in total. Okay, so the answer for this question will be 40 C2, right? And the next one is that we have to select one captain and one vice captain. Okay, so maybe we are selecting A for captain and B for vice captain, or maybe we are selecting B for captain and A for vice captain. Okay, so now we can see that AB and BA are not same here, which means order matters here. Okay, so in that case, we have to use permutation. So it will be 40P2. Okay, now can you understand, can you differentiate between when we have to use permutation and when to use combination?
Yes, ma'am.
Okay, one more example. So suppose we have uh, given n points on a circle. Okay, so how many lines can be drawn connecting these points? Okay, so here also two cases could be there. Okay, so we have a circle on which we have n number of points. N points we have on the circle. Okay, and we know that for making a line we need 2 points only, right? Okay, suppose this is a point A and this is the point B. If you want to draw a line, you need 2 points. Just connect these 2 points and you will draw a line, right? Now here one thing we can see that if this is the segment, one segment AB, if we are making it like a vector, okay, so maybe we are saying that it is a one directional like AB, or it can be BA. Okay, so if they are vector or like going A to B is different from B to A, in that case order will be order matters in that case. Okay, but if we are not talking about any vector kind of thing, okay, we are just making a line, okay, where C D is same as DC. So in that case, we will be using the combination. Okay, so here in this case, we have to use permutation. Okay, but in that case, we have to use combination. Okay, and since we have to use 2 points only for making a line. Okay, so that's why it will be 2 here. The value of R will be equal to 2 in that case. Is this clear to everyone? Any question, any doubt? Hello.
No, but
No,
no
ma'am.
doubts, madam. See, you can continue.
Okay, is it all clear? Yeah, so these are the topics in week 6. So basically, in week 6, you have to study about the combination and how we differentiate between permutation and combination. So these are the things in week 6. If you want to ask any question, any doubt, you can
Uh,
ask.
The tutorial questions, could you please explain, madam? Especially that tutorial question.
Okay, the tutorial questions and activity practice assignment questions we will be discussing in the this doubt session of week 6. So we will schedule the doubt session in this week before Friday, before the deadline. So then we can discuss those questions. If you have any conceptual question, the things that we have discussed today, we can ask.
So only conceptual questions only it will be.
Yeah, whatever we have seen in this lecture, in this session, you can ask.
Can we ask from week 5?
So week 5 doubt session already happened. Why didn't you join that?
Okay, ma'am. Then I'll look into that session.
Yes.
6.1 question number 2.
Okay. We can discuss. I have already told that we can discuss the questions, like activity practice assignment questions. We can discuss in the doubt session.
Okay, ma'am.
Ma'am, I have a question.
Yeah. Yes.
So if we are dealing with any version of combination, but in the list of elements there are duplicates, like how do we like go about questions in that case?
Like the objects are not unique.
Yeah, like some of them are not distinct. Some of them copies, for example.
Okay. Okay. So in that case, you will see like according to the question, we have to see what formula or what thing we have to use. I cannot generalize this question actually. If you have any particular question, then you can ask.
No, I was thinking
At least.
like we did in week 5. So if we have a list of elements and some elements are the same, then we use the usual permutation formula, but we also divide it by the factorial of the
Yeah. So
number,
in
right?
that case, yeah. So you will have to use in that manner.
Also in combination, right? So like just divided by the number of copies of an element factorial.
I cannot generalize this thing. So according to the question and condition given in the question, in that way only I can solve it. So,
Okay.
in different questions, different scenarios are there.
Yeah.
So it's not like that you can use one formula in every question. So you
Right.
will have to see like what question is asking and what conditions and scenarios given.
Can we just have like an example question now? For example, if we have 6
Uh,
and they are just letters from A to E, and A has like 2 copies, then and if we choose like 3, we have to find the total number of ways to select 3 elements. Like if you can solve that.
we have repeat the question.
So the letters are from A to D, so like 5 letters, but A has 2 copies. So we have 6 elements in total, and we need to find the total number of ways to select, for example, 3 elements from this list.
Okay, so you are saying that A and both these two A are different or they are same?
They're the same elements.
Okay, they are the same and you have to select 3.
Yeah.
Okay. So if I make the possible combinations, it will be like A, and D. So these two are same, right?
Yeah, right.
Okay. So generally the combination formula is for the distinct elements only. So we cannot use that formula directly here.
Okay.
Okay, wait. Okay, we will have to see this thing also that whether this thing matters or not, that we can select we have to select the distinct three elements that we are selecting. These should be distinct or not.
Okay.
Okay, like if we can select three things where we can repeat the elements also.
Mm-hmm.
Okay, this can be one case, or another could be we have to select the different elements only. So if we have to select only different things, then in that case we will have to remove one A, I think. And if we can select uh, two A also and one other element.
Mm-hmm. Like if we just select three objects randomly without any constraint, so in that case, is there like a general formula to solve it?
I will have to check this thing one time
Maybe
again.
I have
Okay.
I have something in my mind. Like, see if
Hmm.
we go put a question like, how many ways, how many distinct ways you can spell the word assassination?
Okay. In how many different ones you can spell, like you're arranging the letters, which means, right? Is it correct or not?
Yeah, sorry.
So you are saying that you have a word assassination where you have to spell it, which means like you have to arrange the letters, right?
Yes. And how can I do it in number of distinct ways? So how can I determine the number of distinct ways in which I can do it? Because it has the repeated alphabet. So S repeats itself, A repeats itself, and I guess I repeats also itself. And then there are several letters that repeat itself.
Yeah, so in that case, so we have the formula that you have n total n number of elements, okay, which you have P1 of one type, okay, and P2 of second type, like this. Like P1 number of elements have one type and P2 number of things are another type. So then what we do, we just divide it. Okay, so you have to count the total number of letters in that case. This is the word, right? Okay. So how many total letters are there?
13, I guess. Three.
Yeah, 13 are there. Okay, so and what is your question? Repeat it again.
Yeah, so how many distinct ways you can spell the letter or you can arrange the letters?
Okay, so there is no other condition, right?
No, there is no other condition. It's the only
Okay,
condition.
in that case, 13 factorial divided by, and you have to divide by like S is repeating A. A is 1, 2, 3 number of times, right?
Yes.
Then S we have 1, 2, 3, 4, 4 number of times, right?
Yes.
Then I we have I is 1 and 2 number of times, right? And N we have 2 times. Any other letter which is repeating itself? No, I think.
Not I think. No.
T.
T is not repeating. T is only one time.
Oh, sorry. Was not
Yeah.
getting this.
So then we have to divide it by, like this is 3 factorial, then 4 factorial, then 2 factorial. Okay, and then this 2 factorial. Okay. So total number of elements are 30, in which you have to divide. Like you can see, P1 is of one kind, which means 3. Okay, 3 A's are there. Okay, this is the meaning of this P1. So A is repeating 3 times. So 3 factorial, then P2, which you can say that S. Okay, so S is occurring 4 times. Okay, then 4 factorial and then 2 factorial for I and 2 factorial for n. Okay.
Yeah. Thank you.
Madam, can you tell me how you wrote 2 factorial and 2 factorial?
Yeah.
So
See,
3. Yeah.
this I you can see, I is occurring 2 times only, right?
Yes.
Okay, so this 2 is for I. Now next n is also occurring for 2 times only, right?
Oh,
And A
okay.
is occurring 1, 2, and 3 times, right?
Okay. Got it.
Okay, and then for S is occurring 4 times. 1, 2, 3, and 4. Okay, now T and O are not repeating itself. They are occurring for 1 time only. Okay, so whatever letters are repeating, occurring more than 1 time, so we have to divide it. Okay, so suppose A is occurring 3 times here, so we have to divide by 3 factorial. Then S is occurring for 4 times, so 4 factorial. I is occurring for 2 times, so 2 factorial. And again, N is occurring for 2 times, so 2 factorial. Like this.
It's
Okay.
same concept in the permutation, right? So same way we did repetition will divide, right? So same thing only, right, madam? A repetition we divided, right? So in permutation.
Yeah. So if you see the relation between permutation and combination, this is the relation between permutation and combination. Okay. So in combination, what we do, we just have to select the things. Okay. And so what we have done, out of the n objects, we have selected r objects. Now the thing is that we have to arrange the r objects also. So r objects can be arranged in r factorial ways. Okay. So first we have done the selection and then we have done the arrangement. Okay. Which is equal to the permutation thing.
That's right. Madam, okay, then understood this point. So, madam, so now you related to cricket team, how the peoples are bowlers and the players they selected. That is fine, we understood. And then you explained in the circle there is the when it will be the we need to consider for the factors. Permutation or combinations. If direction is there, so it will be it will be permutations. Without direction, it will be a combination. So that I will understood. So there is similar way that and the cards also you explained to find that's also we understood. So related to throwing dice and tossing the coins. Those points, if you're clarifying, maybe it will be beneficial for me to understand that particular tutorials for me. I thought I
For
hope we
coins
not I
and
hope we are
dice,
not
yeah.
touched. Yeah, I hope we not touched that those examples. Maybe if you are explaining those examples, it will be grateful.
Okay, so we'll have to see the video because that tutorial solutions are like in the video format, right?
No, that is okay, madam. That okay. Now you already told us. So some other session you will explain. I'm
Hmm.
asking that examples how the way you explained the cricket team,
Hmm.
this circle and all, and
Hmm.
cards. Same way that another two topics related to the tossing the coins and continuously we are getting head or tail. Same way throwing the dice. What is the numbers we are getting? So that examples also if you are explaining it would be good for us.
Excuse me, ma'am.
Hmm.
Should I ask something? I want to ask something question that today I got some unofficial link of from result of IITM Foundation results regarding.
Okay.
So should I believe or should I wait for the result? Because in the result they are showing our answer sheet also, question paper also, all the things.
So you have received a link of the result, huh?
Yeah. From unofficial groups of across all over India, students created the group, and I have joined the group. And in the group, the students shared the link, and he said that these results are authentic and verified from IITM.
Okay. And did you find your result there on that
Yes,
list?
I have had I qualified for all the subjects. So my question is, should I start my study on week 6
Sorry.
or should I wait till present?
So results we have not released it yet actually. So
Okay.
you have to wait for I think 2-3 days and then it will be released. I'm not sure that it's real or fake. I
Can I
don't
share
know.
the link? I share the link with you in the group chat. Please check this because some students are saying this is authentic. You can believe and start studying from now.
Okay, I can't say on that link anything because we have not released it yet.
As I opened the link, it's showing that IIT MBA degree, all that real website. I think
Okay, I will see that.
when I click the link, I redirect to a Chrome page and where the all the thing IITM score checker website is showing, and you want to log in with the email ID which you have started the course, enroll in the course, and you get the hall ticket number and all the details of the course, which subject you have appeared.
I can't say anything for that website or that link. Okay, just wait for the announcement from our side because that
Okay,
link you
ma'am.
have
Yeah,
received in an unofficial group, not in the official. Not
Yeah,
officially,
ma'am.
you have not received it.
Okay, ma'am.
Yeah.
Got it. Thank you.
Ma'am, ma'am,
uh,
I have a doubt.
sorry to interrupt. So, madam, so
Yeah,
what I
so
asked,
you were
yeah,
asking about the dice and coin related
yes,
problems.
yes, yeah. That concepts also
So
we are explaining now, so it will be we can understand what is happening. So,
yeah, so the thing is that same kind of points you have to remember there also because there is no general formula that I can explain you right now because if you have any question, then I can explain it because there can be different conditions, different scenarios related to the coin and dice problem. It's not like a general thing that I could explain you.
for
Whatever the concepts are, that you have.
so if you allow me, maybe I'll read that question. So maybe you can give some clarity.
Okay.
Uh, if a coin is tossed 7 times, the
Hmm.
number of outcomes in which at most 3 8s appear are 64. Can you repeat?
We are tossing a coin 7 times.
7 times. Then a number of outcomes in which at most 3 8s appear are
1 minute, tossing
64.
a coin 7 times. Then,
The number of outcomes
okay, 1 minute. Number of outcomes.
in which at
Hmm.
most 3 8s,
At most, three,
3 8s appear
three,
or
eight
or
heads.
64. 8s appear or 64.
Three head, three heads appear
Or
or
ARE or 64.
or are 64.
Yeah. They're telling this is the 64 is the answer, but the how the concept is difficult to understand.
The number of outcomes in which at most three heads appear are 64. So you are tossing a coin 7 times, right?
Okay. So we have two possibilities, head or tail.
Yeah, we have head and tail. So number of outcomes in which at most three heads appear. It's not like a combination permutation thing.
That tutorial this only, madam. So that
Oh,
concepts they are explaining, but we not
okay, I
got
will
the.
see this question and then you can ask me in the doubt session.
Okay,
Okay.
but related to that cricket selection and all, na, so this kind of
Mhm.
examples, if you are provided in this session, it will be good. So it will be complete, uh, complete concepts we understood, feeling I will get.
It seems
In
to
which
have a
tutorial
very
this question is given?
Tutorial 3,
Okay, okay,
week 6, tutorial 3.
okay, okay. Anything else?
That
In this
that only.
coin,
Yeah, you continue, madam.
Hmm. Yeah, anything else from anyone?
Ma'am, I have a question. Can you draw 3 individual boxes naming red, green, blue?
Red, green, and blue.
Yeah, fine. So we have 10 red balls,
Okay, 10 red balls.
6 blue balls, and 5 green balls.
Hmm.
So possible ways of getting 2 blues and 1 green out of all.
2 blue,
Yeah, 2 blue and 1 green.
1
Maybe
green.
on the right, yeah, maybe on the right side, you can again draw 3 boxes. So if I see, if I see the result, it should be BBG. So 2 blue balls and 1 green. So
Okay, how many balls in total we are selecting?
sorry,
Only
your
3.
voice is breaking.
Yeah, I am asking that your question is that we have 10 red balls, 6 blue balls, and 5 green balls, right?
Yes, yes.
Okay, and how many balls we are selecting in total?
3
We are
balls when
selecting.
I arrange. Yeah, selecting.
Okay.
We are picking 3.
Okay, we are picking only 3 balls.
Yes. So what is the possibility of getting BBG? 2 blues and 1 green.
Okay, so total number of ways we are talking about. Okay,
Yeah.
so out of 6, so we have to select 2 blue balls and 1 green ball,
Yes.
right? So we can see that we don't have to select any ball from red. So just discard this part. So out of the 6 blue balls, we have to select 2 balls. And out of the 5 green balls, we have to select 1 green ball.
Yeah.
Okay. So this will be the total number of weights. Okay, total we are selecting 3 balls only, right?
Yes. You're correct.
Yeah, so that will be the answer.
Okay. Thanks.
Okay, anything else? Okay, then if you don't have any question, then we can end the session. Thank you everyone for joining.
Yeah. Thank you very much for explaining the concepts.
Yeah, okay. Thank you everyone.
Thank you.
Bye.